Everything around you, every star, every planet, your own body, exists because of something that should never have happened. According to physics, matter should not exist at all. And yet, here you are. At the beginning of the universe, in the first fractions of a second after the Big Bang, an enormous amount of energy converted into particles. But every particle created came with an opposite twin, a mirror version with the same mass but reverse charge. For every electron, there was a positron. For every proton, an antiproton. This mirror substance is called antimatter, and by every law of physics we understand, it should have been created in exactly equal amounts to ordinary matter. That equality should have been the end of everything. Matter and antimatter cannot coexist. The moment they touch, they annihilate each other completely, converting entirely into pure energy. If the early universe truly created matter and antimatter in perfectly equal amounts, they should have collided, canceled out, and left behind nothing but a hollow universe of light. No galaxies, no stars, no planets, no life. Just an endless glow fading into darkness. But that is not what happened. Somehow, for every billion antimatter particles created, there was one extra particle of matter, a tiny, almost impossible imbalance. When the Great Annihilation occurred, nearly everything destroyed itself. But that tiny surplus of matter survived. Everything you can see in the universe today, every galaxy, every star, every planet, every person who has ever lived, is built entirely from that leftover fraction. We are, in a very real sense, the scraps of a cosmic explosion that was never supposed to leave anything behind. Scientists call this the baryon asymmetry problem, and it remains one of the most significant unsolved mysteries in all of physics. The Standard Model, our best description of how particles behave, predicts that matter and antimatter should have been created in equal amounts. It offers no explanation for why one side of that equation won. Some researchers believe the answer lies in a subtle difference in how matter and antimatter particles behave, a violation of a principle called charge parity symmetry. In certain rare particle interactions, matter and antimatter do not behave as perfect mirror images of each other. These tiny asymmetries have been observed in laboratories, but they are far too small to fully explain the massive imbalance that allowed our universe to exist. The gap between what we've measured and what we need to explain reality is enormous, and closing that gap remains one of the great unsolved challenges in physics. To search for answers, scientists have built extraordinary machines. At CERN, the world's largest particle accelerator sends particles crashing into each other at nearly the speed of light, recreating conditions similar to the earliest moments of the universe. Inside detectors like Alpha and Aegis, researchers have even managed to create and trap anti-hydrogen atoms, assembling antimatter atom by atom, just long enough to study how they behave before they inevitably meet ordinary matter and vanish in a flash of energy. These experiments have revealed something strange. So far, antimatter appears to obey gravity in exactly the same way ordinary matter does, falling downward, not upward, as some early theories once speculated. This rules out one exotic explanation for the imbalance, but it deepens the mystery rather than solving it. Whatever caused matter to win over antimatter, it isn't something as simple as antimatter behaving in some completely opposite way. There are theories that go even further. Some physicists propose the existence of entirely new particles, ones that existed only in the earliest moments after the Big Bang, that could have decayed in a way that favored matter over antimatter. Others suggest that neutrinos, some of the strangest and most elusive particles in existence, could hold the answer, potentially behaving differently from their antimatter counterparts in ways not yet fully measured. If confirmed, this could help explain where the missing symmetry went. What makes this mystery so extraordinary is not just its scale, but its intimacy. This isn't a question about some distant galaxy or an event from billions of years ago that has no bearing on us. This is a question about why matter, the very substance you are made of, exists at all. Every answer we uncover about antimatter is, in a strange way, an answer about your own existence. For now, the imbalance remains unexplained. We know it happened. We can measure its effects everywhere we look. But we still don't fully understand why the universe chose matter over antimatter, why the scales tipped ever so slightly in favor of existence itself. Perhaps the answer is hiding inside a particle we haven't discovered yet. Perhaps it will come from an experiment already running today, deep underground, colliding particles at unimaginable speeds. Or perhaps the truth is stranger than anything we've imagined so far, a piece of physics that will completely reshape how we understand the universe's very first moments. Whatever the answer turns out to be, one thing is certain: the universe was never supposed to leave anything behind, and yet it did. If this made you think differently about how close the universe came to erasing itself, and how lucky we are that it didn't, hit like, subscribe, and join us for the next journey into the unknown.